Swayam Prabha. Digital India. Educated India.
Hello viewers, welcome to lesson 4.7 which is on pavement materials part 4, and in this lesson we will be covering bituminous binders. This is a lesson which is being delivered under the module 4 which is on pavement design. Just to recap what we discussed in the previous lesson, which was lesson 4.6, which was also on bituminous binders. We have learnt about different types of binders used in pavement construction. Rather, we have listed various binders that are normally used in bituminous binders, that is bitumen, tar, emulsion, cutback and modified binders. Then we discussed about the process of producing bitumen from crude oil by different refining processes. We also discussed briefly about the chemical composition of bitumen, and we learnt about various methods that we adopt for testing the rheological behavior and other properties of bituminous binders. Some of the tests that we considered were penetration test, ductility test, softening point test, frost breaking point, dynamic viscosity. Obviously, these tests do not completely cover the complete gamut of tests that we could do on bituminous binders, and we have in the previous lesson only covered certain aspects of testing and evaluation of normal bitumen. In this lesson, we will go ahead and then discuss about a few other tests that we can do on bituminous material and the relevance of those tests and the test procedures. So, as stated, the main objective of this lesson is to make the student learn about some additional tests other than what we have already discussed in the previous lesson. So, we will be discussing a few additional tests that we can conduct on bitumen, their relevance, test procedures. We will also try to understand the phenomenon of aging of bitumen. It is also expected that the student would be able to understand the concept of temperature susceptibility of bituminous binders, and the student should also be able to learn about different systems of grading bituminous binders, and we will also discuss about another type of bituminous binder which in fact is bitumen, but in a different form, that is about cutbacks, their use in pavement and the tests that are to be conducted on cutbacks. In the previous lesson, we discussed about dynamic or absolute viscosity, which as we said was a fundamental parameter of bitumen. It tells us great deal about the rheological behavior of bitumen. Rheology, as we mentioned in the previous class, is the study of flow and deformation behavior of any material. So, as we know, at different temperatures for different loading times, bitumen does undergo flow. So, we are concerned about the rate of flow, the manner in which it flows at different temperatures and when subject to different loading times, and what is the implication of these flow characteristics, these deformation characteristics as far as the pavement performance is concerned. While it is a very useful parameter to talk about absolute viscosity, but it does not take into account the inertial force. In many situations, we are interested in the ratio of viscous force to the inertial force. A very convenient unit for this purpose is the kinematic viscosity. Defined as the ratio of dynamic viscosity. I think mu was the parameter that we are using, and the density of the fluid rho. So, the kinematic viscosity can be defined as absolute viscosity or dynamic viscosity divided by the density of the fluid. The SI units for kinematic viscosity is meter square per second. The CGS unit is centimeter square per second, or more commonly Stoke is the unit that is normally used. Even more commonly, it is centistoke that is used. Obviously, we know 1 stoke would be 100 centistoke. How do we measure kinematic viscosity? Because as I said, this is a very convenient unit. If you want to express viscosity in terms of viscous force and the inertial force, then kinematic viscosity is a convenient unit. We use efflux viscometers or capillary viscometers to measure kinematic viscosity. What is done with these viscometers is in principle this. There is a standard orifice. Obviously, there is a viscometer which is a container. It has a standard orifice. Bitumen is collected in that, and which is maintained at a specified temperature. So, obviously, we have to specify a certain temperature. At the temperature, when the bitumen is maintained, the stopper that is put in the orifice will be opened and the fluid is allowed to flow. The time taken, time required for certain quantity or certain volume of fluid to flow through this specified orifice is measured in terms of time unit. So, viscosity in this case is expressed as the time taken for a standard volume of fluid to flow through a specified size orifice at a specified temperature. But normally, we can express we can have specifications in terms of directly in terms of seconds as a viscosity unit, or this time unit can be converted into kinematic viscosity or even the dynamic viscosity using appropriate calibration factors. These calibration factors will be different or dependent on the type of equipment that we are using, size of the orifice that we are using, and other relevant parameters. So, on the left hand side we see the orifice being plugged, and at the bottom there is a container which is placed to collect the fluid. On the right hand side, once the orifice is open, fluid starts flowing. If it is a viscous material, it would normally naturally take more time. If it is a less viscous material, the required quantity of binder can be collected within shorter time period. But the time, as I said, can be in seconds, expressed in viscosity can be expressed in seconds, but normally this is expressed in terms of kinematic viscosity units, either Stokes or centistokes, using appropriate calibration factors, which again are a function of the equipment that we are using and the size of the orifice. These two photographs show two typical viscometers. Left hand side you have standard tar viscometer, which normally used to measure viscosity of tar. On the right hand side you have Seibold Furel viscometer, which is used to measure the viscosity of bitumen, emulsions and other types of binders. next type of viscometers that we normally adopt for measuring kinematic viscosity is the capillary viscometer. What we have in this case is different types of capillary tubes are there, and we measure the time taken for the binder or the fluid to flow through these capillary tubes, and the time that is required for certain quantity of fluid to flow through these tubes is measured, and that is the viscosity unit that again has to be calibrated, and then using the appropriate calibration factors we can get the kinematic viscosity. There are various types of capillary tubes available, different sizes. There are marks that are provided on these capillary tubes, which would indicate or rather serve as a marks to identify when certain quantity of fluid has flown from one point to another point, and the corresponding times can be noted, and the time required for certain amount of fluid to flow from one mark to another mark can be obtained. The corresponding calibration factors are available from the manufacturer depending on the size of the capillary tube and the arrangement of bulbs and other arrangement that we have here. Here we see an arrangement that we normally use for a capillary viscometer. What we in fact see here is a temperature bath, which is used to maintain constant temperature. The capillary tubes are capillary viscometers, which are basically glass tubes of different arrangements, are placed inside this, and then depending on the temperature that has to be maintained, different mediums can be used including water, and normally we should have a proper constant temperature arrangement has to be there. In some cases, depending on the viscosity of the fluid that is to be measured, which again is a function of the test temperature at which you are conducting the test. If it is a smaller temperature, the viscosity of the fluid will be more. Then there is a vacuum arrangement that will have to be applied for certain test procedures. So, there are various arrangements that are possible with vacuum, without vacuum. Different types of capillary tubes are available. For each arrangement, there is a separate calibration factor that is available. Once you get those timings from this testing arrangement for a given temperature, we can get the corresponding kinematic viscosity. We are also interested in the specific gravity of bitumen. Normally, this is determined using a pycnometer and at a temperature of 27 degrees centigrade. Normally, specific gravity of bituminous binders or rather bitumen ranges from 1.02 to 1.04. It can be different from this also. In general, the specific gravity of bituminous binders does not influence the behavior, mechanistic behavior of these binders. Normally, we conduct this test to actually find out or for quality control purposes, to ensure that we are getting the type of binder that we have been looking for. We know for 60-70 typically the specific gravity could be in a different range. Similarly, 30-40 it can have different specific gravity, of course from a particular source. So, this can be used as a quality control measure, but more importantly this is used in converting the weight of bitumen into corresponding volume, because as we mentioned once in earlier lesson, we are going to use the volumetric analysis of the bituminous mix for designing the bituminous mixes, because the bituminous mixes volumetric proportions have been found to be better correlated to the performance of the pavements. So, mix design is normally in terms of volumetrics. So, that is why we should be able to convert all the components that we are using in a bituminous mix into the corresponding volumes. So, for that reason we also need the specific gravity of bitumen. Coming to the aging of bitumen, this is a phenomena that we need to understand, because like all human beings or most materials, bituminous binders are also going to be aging with time. So, this is a time dependent process, but some of the changes that occur in bitumen with time are for good, most of them are not for good. So, we would try to understand what happens as bituminous binders age, they start aging with time, and what exactly happens. Bituminous binders basically undergo aging due to the loss of volatile matter and oxidation. We know that there is certain amount of volatile matter present in bituminous binders. With time and in certain conditions, the volatile matter is going to be lost. So, that is one change that is going to happening to the bitumen with time. The other change is the components of bitumen, as we discussed in a broadly speaking terms, asphaltenes, resins and oils, they get oxidized. Oil could get oxidized to form resin and asphaltene. Similarly, resin can get oxidized to form asphaltenes. So, there is going to be some change in the chemical characteristics of the binder with aging. The aging usually happens in two different phases in the life of the bituminous binder that is used for constructing pavements. One is short term aging. This happens over a very short time period. This happens because the bitumen is heated to high temperature, it is mixed with aggregates, and when it is coating the aggregates, it is in a thin film. The thickness could be of the order of maybe 5 microns, 10 microns, 15 microns. It is so thin. So, it is coating the aggregates in the form of very thin films, and it is heated to very high temperatures 150, 160, 170. At that high temperatures and then in thin films, it is going to be oxidizing very rapidly. Also, during storage, during transportation, usually it is at high temperature, depending upon the area of surface that is exposed to the atmosphere, exposed to air, the amount of oxidation could be different, and the method in which we are going to mix it, how we are going to place it. So, all these things affect short term aging. Usually, significant amount of aging occurs during this short term aging because of high temperatures, because of the bitumen being in very thin films. Significant amount of change occurs during the initial short term aging, but there is some amount of aging that occurs after this short term aging also, while the bitumen is in the pavement, while it is in service over a period of 5 years, 10 years, 15 years during its service life period, some amount of aging is going to occur. This aging that occurs during its service life period is known as long term aging. So, long term aging also occurs due to oxidation occurring during the service life. This oxidation, the amount of oxidation that is going to be there, rate of oxidation that is going to be there, would be a function of what the bitumen is exposed to, what is the air void content of the mix that is there. So, accordingly, what is the air that is going to be present within the mix, then that is going to be conducive for oxidation of the binder, and then other climatic factors including humidity, temperature and so on. Because of aging, bituminous binders become harder and stiffer. So, with time the binders go on becoming harder and then stiffer. Because of this, the penetration decreases with aging. We know smaller the penetration value, harder the bitumen, larger the penetration value, softer the bitumen. So, with aging the penetration value gets reduced, that means the bitumen becomes harder. The softening point increases. For bitumens having smaller penetration value, the softening point will be higher, but bitumens having larger softening penetration value which are softer, the softening point will be smaller for obvious reasons. Also, the viscosity increases with aging and ductility decreases, it becomes brittle. How we measure the aging characteristics of bitumen is using, there are various methods, but most commonly used methods are, especially short term aging is measured by equipment called as thin film oven. As the name suggests, the bitumen is going to be prepared in thin films and it is subjected to aging. There is a more recent version of thin film oven, which is a rolling thin film oven, which is slightly more advanced, and the claim is that it simulates short term aging better, and the time required for short term aging to simulate the short term aging with rolling thin film oven is also going to be shorter. In RTFO or TFO, what we do is the bituminous binder is kept as a film at high temperature, which is 163 degree centigrade for a specified time period. The specified time period will be different for RTFO, different for TFO. So, the properties of the binders after aging and before aging are compared to assess the effect of aging on the binder. So, normally we have specifications to assess how much is permissible, what reduction of penetration is permissible, what increase of softening point is permissible after aging, when it is tested in TFO, when it is tested in RTFO. Obviously, different specifications have to be there, because these are different testing conditions. So, we test different properties of binder before TFO and after TFO, then compare these two properties, see whether the bitumen has got the susceptibility of aging too much or whether it is an acceptable aging process. Pressure aging vessel is an equipment that is normally used to simulate the long term aging that occurs over long period in pavements. Pressure aging vessel is especially for Indian context is still a costly equipment, although some agencies have it. What is done in this case is the binder is kept at maximum service temperature or a temperature that is specified for a given site, a given project location. So, obviously, the temperature is going to be different for different project locations, and the binder is subjected to pressure certain time period. After that, the properties of the binder are evaluated. So, this process is expected to simulate the long term aging that is going to happen to the binder when it is used in a pavement. Normally, the binder that has been aged in either TFO or RTFO, usually it is RTFO aged binder that is used, that is a binder that is used in PAV. So, first the binder is short term aged in RTFO, then it is put in a PAV, pressure aging vessel, then subjected to pressure, specified magnitude of pressure, maintained at a specified temperature. This temperature is a function of the location at which the material is going to be used. Then after this long term aging, the properties of the binder are going to be evaluated. What you see here are two actually views of thin film oven. Left hand side you have thin film oven with the outside view, door closed, and right side you have the thin film oven, interior details are given. You have certain cups also available. There are two shelves that are there. So, there are some discs that can be placed in it, and then bitumen will be put in that. So, and then this arrangement is going to be rotating at a constant speed. Because of that, the binder is going to be spread in thin film. It in fact is not as thin as you will have in the case of the bitumen coating in aggregate. It will not be as thin of 5 microns, 10 microns, 15 microns. It will be much thicker than that, but still it is a film. And then this is subjected to 163 degree centigrade, and then it will continuously be rotated. Compared to this, what we do in the case of RTFO is, besides formation of a film, the film is going to be much thinner than this. There is going to be air that is going to be blown onto the bitumen, which would further accelerate the oxidation process. We will now discuss about the temperature susceptibility of binders. We know bitumen is thermoplastic. It becomes soft when hot and hard when cold. What we are concerned about is the variation in the consistency, that is, consistency can be in terms of penetration, softening point, viscosity or any other parameter, stiffness, modulus value. of the bitumen with temperature. The variation in consistency, again either in terms of penetration, viscosity or any other parameter, with temperature is known as temperature susceptibility. This is normally measured, this can be quantified by conducting either the viscosity test or the penetration test or any other test which would give you a parameter like stiffness, modulus value and other parameters at different temperatures. If that parameter can be obtained at different temperatures, that variation can be examined, then we can quantify or express how temperature susceptible different binders are. In this case, we have chosen penetration to represent the temperature susceptibility of bitumen. What is done is, penetration test is, let us say, conducted at different temperatures, say at 4 degree centigrade, the corresponding penetration is obtained, say 25 degree centigrade, the corresponding penetration obtained. If we can conduct the penetration test at other temperatures, let us say we obtain number of points like this, and let us say we get a straight line. Normally we expect to get a straight line if it is plotted on a semi log scale, penetration being in on log scale. So, the slope of this line A is called as the temperature susceptibility of the binder. For typically for paving binders, this value is going to be about 0.015 to 0.06. So, if we can get the value of A for a given binder, we have some idea about what is going to be temperature susceptibility of the binder. Obviously, flatter the line, lesser the temperature susceptibility, steeper the line, it is obviously more susceptible, because the property is going to vary for a given variation in temperature, the property is going to vary more significantly for a steeper line. So, larger value, that is a value of 0.06, if you get a value of the 0.06, it should be considered to be highly temperature susceptible. A value of 0.015 obviously is not so temperature susceptible. But penetration index is a more convenient parameter to represent the temperature susceptibility. Penetration index has been correlated to the temperature susceptibility parameter A we have seen in the previous slide as given below. That is 20 minus Pi divided by 10 plus Pi is equal to 50 A. Our expression in terms of Pi, it is given as 20 into 1 minus 25 A divided by 1 plus 50 A. Pi normally ranges from minus 3 for highly susceptible bitumens. These are highly temperature susceptible bitumens if you get a value of minus 3, plus 7 low temperature susceptibility. You get such high values especially for highly blown bitumens, when these bitumens are already blown, oxidized to significant amount. So, they are not going to be so temperature susceptible compared to straightened bitumens. For determining penetration index, it can be obtained by obtaining obviously the value of A, which is the temperature susceptibility on a penetration versus temperature plot. A can be obtained if you can conduct the penetration test at two different temperatures. So, log penetration at temperature 1 minus log penetration at temperature 2 divided by the temperature difference T 1 minus T 2. Most bituminous binders have a penetration value of about 800. This is an observation that has been made on the basis of tests that are conducted, or rather that were conducted on a number of binders, but it is not that all binders are going to exactly have this value. This is a penetration value that can be expected if the test temperature is equal to softening point temperature. We are getting similar penetration value for all binders irrespective of whether it is 60, 70, 30, 40 or 80, 100 at softening point temperature, because softening point temperature represents a specified degree of consistency. So, irrespective of what binder it is, what happens at softening point temperature, what is the fluidity that is attained by all these binders is more or less similar. That is the reason why we get more or less similar value, which is about 800 for all binders at the corresponding softening point temperatures. So, for example, 3040 you may have to test it at maybe 52 degrees centigrade, 8000 you may be testing at 45 degrees centigrade. If that is the softening point, corresponding softening points, then the penetration values that you can expect for these two binders at those temperatures is about 800. 800 means that is about 80 millimeters. So, making use of this assumption or the experience. So, one of the temperatures will be softening point, the corresponding penetration is 800. Also making use of the penetration test result, which is the penetration that we obtain at 25 degrees centigrade. So, that is that temperature is 25. So, making use of the softening point test, from which we get the softening point value, the corresponding penetration value is assumed to be 800. From penetration test we get the penetration test temperature 25 degrees centigrade. The corresponding penetration is of course what we report as the penetration of the binder. So, making use of the results that we get from these two tests, we can calculate the value of temperature susceptibility, and from this of course we can calculate the penetration index. So, using those results and further simplification gives you penetration index value as 1952 minus 500 times log penetration minus 20 times softening point whole divided by 50 times log penetration minus softening point minus 120. So, if you know the softening point value, if you know the penetration value, penetration index can be computed. Let us now discuss about the gradation of bituminous binders. Any material when we select for construction, we have to specify a certain grade of material has to be provided to you, class 1 bricks, class 2 bricks, 53 grade cement and so on and so forth. So, every material has to be graded, most materials have to be graded. Most commonly adopted grading system is penetration grading, which is done on the basis of penetration determined at 25 degrees centigrade. There is another grading that adopts viscosity value determined at 60 degrees centigrade. So, the grading is done on the basis of the value of viscosity obtained at 60 degrees centigrade. There is another more recent method of grading bitumens has come up, which is known as performance grading, also known as super pave performance grading, because this has come out of a experimental study that has been conducted for developing superior performing pavements, super pave. In performance grading, the binders are graded by the conditions, usually the temperatures, service temperatures that the binder is expected to perform, at which the binder is expected to perform satisfactorily. So, obviously, these are selected in such a way that they are going to be suitable for a given location. So, for a given project site, if you identify what are the maximum temperature, what are the minimum temperature, service temperatures, then the performance grading is going to give you a binder which is going to be satisfactory under those conditions. Instead of giving you that at 25 degrees centigrade this binder will have 80 penetration, or at 60 degrees centigrade temperature this binder is going to give you so much of viscosity. Instead of that, this is a system which will give us which will help us in selecting a binder that will perform satisfactorily over a given range of temperature which are specific to a given project site. Penetration grading, normally we have various grades. The S prefix that we have here on the left hand side stands for straightened bitumen. Obviously, these are not blended, not modified, not blown bitumens, these are straightened bitumens which are not modified. So, S 35 is the average of the range for 30-40 range. S45 means this is a binder which is expected to have 40 to 50 penetration, that means 4 to 5 millimeters penetration of the specified needle. Similarly, S55, 65, 90 and 200 penetration. The problem with penetration grading is this is a very simple method, because determining penetration is very easy, but this is empirical. The property is not a fundamental parameter, and it does not really tell us much about the rheological behavior of the bitumens. And also we cannot grade polymer modified binders and other modified binders using penetration gradation, because two different binders having similar penetration have been found to be giving different performances while used in field. So, from experience it has been found that penetration grading is not a good system to grade all types of binders. It also does not give us adequate guidance regarding the mixing and compaction temperatures to be used, because on the basis of penetration at different temperatures, because mixing and compaction are done at very high temperatures 150, 135, 100, 110, around those temperatures, but penetration normally we do not carry out penetration test at such high temperatures. We may conduct it at 25 degree centigrade, or it may also be conducted at 4 degree centigrade. With special effort we can still conduct penetration test maybe at 60, but conducting penetration test at very high temperatures is not normally feasible. So, viscosity corresponding to mixing operation or compaction operation is related to higher temperatures. So, we do not normally get an idea about on the basis of penetration test. We cannot formulate any specifications for mixing temperatures, compaction temperatures and other related parameters. Also, penetration grading specifications do not provide a good idea about the temperature susceptibility, because we cannot normally conduct test penetration for over wide range of temperatures. As I just indicated a few minutes ago, it is not normally possible to conduct penetration test at higher temperatures. So, we cannot get the temperature susceptibility, although we can conduct at 4 degrees, we can conduct at 25 degree centigrade. So, that will give you some idea about what is the temperature susceptibility, but over much wider range of temperatures that is not possible. Viscosity grading is on the basis of viscosity measured at 60 degree centigrade. There are various viscosity grades that are available, AC 2.5, AC 5. In India we still do not use viscosity grading, what we use is penetration grading. AC 5, AC 10, AC 20. AC indicates asphalt cement, that is bitumen, and 2.5, if it is to AC 2.5 bitumen, it means at 60 degree centigrade its viscosity is going to be around 250 plus minus 50 poise. AC 20 grade bitumen will have a viscosity of about 2000 plus minus 400 poise at 60 degree centigrade. S60, S90, these are 60-70 bitumen, 80-100 bitumen that we normally use in India. In terms of the viscosity that we normally get for these binders, they can correspond to AC 30 and AC 10 binders. Viscosity grading is more fundamental, because compared to especially penetration grading, because we are talking about we are using a more fundamental parameter which is viscosity. Bitumens having similar viscosities normally give similar rutting performance, that is similar permanent deformation performance. That means, there is a better correlation to what happens actually in field in terms of permanent deformation of those bituminous mixes to viscosity rather than penetration. So, the correlation to penetration, as I said earlier, two different binders having same penetration may not reflect similar type of rutting performance, whereas bitumens having two different bitumens having similar viscosities more or less will give you similar rutting performance. And we also get better guidance for mixing and compaction temperatures, because viscosities can be measured at higher temperature also, especially if you are using rotational viscometer or Brookfield viscometer. We can definitely measure viscosities at much higher temperatures. So, then we can formulate guidelines in terms of viscosities for mixing, compaction. Coming to performance grading, this has been a result of a $50 million 5-year long strategic highway research program, popularly known as SHARP, conducted in the United States of America. These are also called as superior performance payments, performance gradation. In this, the binders are graded by the temperature range, high and low, within which the binder has appropriate properties to perform satisfactorily. Against rutting mode of failure, against fatigue failure of bituminous mixes, which is at intermediate temperatures. Rutting mode is to be considered for high temperature instances, this is high service temperature. Fatigue failure to be considered at average service temperatures, and low temperature cracking, this is low service temperature. So, these are basically the three modes of failure that are considered in formulating the specifications for performance gradation. So, the binder is selected in such a way that for a given temperature range, these three failures can be tackled if the binder that has got appropriate properties within the temperature is selected. Performance grading is based on engineering principles and addresses common bitumen pavement problems like rutting, fatigue cracking, and in some specific areas low temperature cracking, where minimum temperatures can go very low, -10, -15. The tests and specifications are applicable for unmodified and also modified binders. It does not specify, there is no mention of whether it is a 60-70 binder, 30-40 binder, modified binder, neat binder. Irrespective of the binder type, it can be generalized. The physical properties measured as per this method are directly related, because we in this specification will not be talking about penetration, will not be talking about generally not be talking about softening point. The specification will be in terms of more fundamental parameters. So, this is a more complex system requiring more complex testing procedures. However, in spite of all the complex methodology and then costlier equipment that one needs to use, this is considered to be very rational. So, these properties that we are expected to determine in this procedure are directly related, are better related to the performance of the binder in terms of engineering principle and not just simply by experience. These specifications are available for long term aged bitumens also. The complete range of temperatures experienced at a given site are considered for selecting an appropriate grade of bitumen for the site. So, this is the most important thing. The bitumen that is selected for a given project is going to be performing satisfactorily within a temperature range. For example, if we designate a binder as PG 58 -12, that is -12, this represents a binder that is expected to perform satisfactorily in a region having 7-day maximum pavement temperature of 58 degrees centigrade and minimum pavement temperature of -12 degrees centigrade. Let us examine a few specifications that Indian Standard 73 specifies for S65. Similar specifications are available for other types of bitumens also. Considering the characteristics and the corresponding requirement, specific gravity minimum of 0.99. As we know, these are tests that are corresponding to purity of the binder. Water percentage by mass should not be more than 0.2%. Flash point, which is a test that we conduct for safety concern, minimum of 175 degree centigrade. Softening point normally ranges between 45 to 55 degree centigrade. for 60-70 binder, this is a S65 bitumen that we are talking about. Penetration obviously has to be 60-70, between 60-70. Penetration ratio should be a minimum of 35. Penetration ratio is obtained as penetration ratio determined at 4 degree centigrade with 200 grams mass and then 60 seconds time period, and penetration at 25 degree centigrade 100 grams and then 5 seconds time period, expressed as percentage. So, this should be a minimum of 35. This ensures that the temperature, the penetration value does not change significantly over this temperature range of 4 and 25. Other specifications for S65 bitumen are ductility minimum of 75 centimeters, that means at a temperature of 27 degree centigrade the standard briquette should be, we should be able to extend the briquette up to a minimum distance of 75 without the briquette breaking. Similarly, the paraffin wax content should not be more than 4.5%. The frost breaking point, which is the temperature that represents the low temperature behavior of bitumens. So, it should be a minimum of -6 degree centigrade. Loss on heating after we put the bitumen in TFO apparatus, after that the loss of mass should not be more than, which obviously should be the loss of volatile matter, should not be more than 1%. The retained penetration, this is the ratio of penetration that is obtained after TFO test of the binder compared to the original penetration of the original binder, it should be a minimum of 52% for S65 binder. Again coming back to the purity, matter soluble in trichloroethylene should be a minimum of 99%. Viscosity at 60 degree centigrade expressed in poise should be 2000 plus minus 400, and viscosity measured at 135 degree centigrade in centistoke should be a minimum of 300. These are the guidelines that are normally available for selecting binders for different pavement purposes depending upon the traffic loading expressed in terms of 10 to 30 million equivalent standard axle loads. We discussed about what is standard axles and other aspects when we in the lessons that we which covered traffic related aspects, and here we are using T maximum, which is the highest monthly average maximum temperature for the project location, and T minimum, this is the lowest monthly average maximum temperature, this should be minimum temperature for the project location. So, for these conditions we can select the appropriate binder. For example, for 0 to 10 degree temperature 90, 90, for higher temperatures we are going for stiffer or harder grades of bitumen, 40 to 50 degrees temperature, and then even the low temperature is more than 20, these are generally hot conditions, we are going for 35 grade 30-40 bitumen. If the traffic volume is less than 10 million standard axles, this is for 10 to 30, then we can adopt whatever this table suggests, we can adopt one grade softer, or if it is more than 30 million standard axles, we can adopt one grade harder. Next we will briefly discuss about cutbacks. Because straight run bitumen requires heat to reduce its viscosity for various applications, because we have to heat bitumen at normal temperatures, we cannot spray bitumen, we cannot coat bitumen onto the aggregates. Cutbacks are nothing but low viscosity bitumens. These are obtained by lowering the viscosity of the bitumen using a volatile solvent. The low viscosity of cutbacks at normal temperatures alleviates the need for heating. We do not need to heat cutbacks, we can straight away apply the cutbacks straight away. But after application, the volatile matter will have to evaporate and should leave behind the desired quality and quantity of bitumen. What we ultimately require is bitumen to be coating the aggregates. Volatile matter is only there to reduce the viscosity and enable us to use it, apply it. Once we apply it, after certain time period, the volatile matter should go away and leaving behind actual bitumen, quantity of bitumen that we require. There are various types of cutbacks that are available depending upon how fast the volatile matter gets evaporated. Rapid curing, in which naphtha or gasoline is used as a solvent. Medium curing, kerosene is used as a solvent. Slow curing, diesel or lubricating oil is used as a solvent. As you can see, the boiling points are of these materials gradually go on increasing. So, it takes more time for diesel to be evaporating compared to petrol. Curing is the evaporation of solvent from cutback. Also, depending on the initial viscosity of the cutback at 60 degree centigrade, the cutbacks are further classified as rapid curing. For example, RC 70, RC 250, RC is obviously rapid curing, 70, 250, 800, 3000 and so on. Similarly, for slow curing, SC 70, SC 250, SC 800 and so on. The suffix, the number indicates the kinematic viscosity of the cutback at 60 degree centigrade. The application of cutback is rapid curing cutback is normally used with aggregates containing practically no fine aggregates. Fine aggregates being the portion of the aggregates passing 2.36 millimeter sieve. Medium curing aggregates are normally used with aggregates having less than 20% fine aggregates, and slow curing cutback is used with aggregates having more than 20% fine aggregates. But being environmentally hazardous and considering the risk in handling this material because of the volatile material that is there, the use of cutback is generally discouraged except in special conditions. So, nowadays the use of cutbacks, especially in highway projects, is not permitted unless special conditions persist. These are some of the specifications for cutbacks. This is in terms of kinematic viscosity at 60 degree centigrade, flash point, and the residue that is obtained after distillation, because we are interested in finding out what is the quantity of bitumen that is available and the property of the residue determined in terms of its viscosity. To summarize, in this lesson we have discussed about the kinematic viscosity of bitumen and its measurement, because in the previous lesson we talked about the absolute viscosity or the dynamic viscosity. In this lesson we have also discussed about the phenomenon of aging of bitumens. We also talked about temperature susceptibility of bituminous binders. We learned different systems of grading bitumen. We have discussed the rationality of different systems for grading bitumens. We have also learned about cutbacks and their use in pavement construction. So, let us take some questions from this lesson. Answers to these questions will be provided in the next lesson. Question number 1: what is kinematic viscosity and what are its units? Question 2: what is the difference between short term aging and long term aging? Question 3: what is the significance of studying temperature susceptibility of bituminous binders? Question 4: estimate the PI value, that is penetration index value, for a binder having a penetration value of 65 and softening point of 48 degree centigrade. Question 5: what are the commonly adopted systems of grading bitumens? Question 6: what does PG 64 minus 16 stand for? Question 7: what does MC 250 stand for? Now, let us discuss the answers to the questions that we have asked in lesson 4.6. Is star different from bitumen? Yes, star is significantly different from bitumen in terms of its origin, in terms of the chemical composition, in terms of how it is produced, and also in terms of its physical characteristics. So, tar is a different material which is produced from destructive distillation of coal, a coal tar, rather bituminous coal, whereas bitumen can be naturally occurring or produced from crude. What is gilsonite? Gilsonite is a naturally occurring bitumen which is very hard and brittle, and occasionally it is used to blend with other normal bitumens to increase its stiffness, reduce its penetration and increase its softening point. How do the properties of bitumen get affected by blowing in a refinery? By blowing, what happens is the oxidation of various chemical components of bitumen. As a result, the penetration gets reduced, the penetration value gets reduced, softening point gets increased, viscosity gets increased. So, that is how blowing affects the properties of bitumen. What are the temperatures we are generally concerned about while studying the behavior of bitumens? While studying the behavior of bitumens, we are concerned about very high temperatures, for example, 135, 150, which are relevant for mixing, transporting and then other handling operations, spraying, etc. Whereas, as far as the performance of bitumen while in service is concerned, minimum service temperature it could be -10, -15 and maximum service temperature usually 60 degrees centigrade and average service temperature which is about 25 degrees centigrade. So, we determine the properties of bitumens at these temperatures. What are the standard test conditions for penetration testing of bitumen? The standard conditions that we have to adapt is 100 gram mass, 5-second time period and then 25 degrees centigrade temperature. What is the significance of frost breaking point test? This is a test conducted to evaluate the low temperature behavior of the bitumen. Not very relevant for most parts of India unless we are facing with low temperatures as low as -10, -15. What is the significance of ductility test? This test gives us an indication as to how much the bitumen can be stretched at a fixed temperature, how far the bitumen films can be elongated at a given temperature. Thank you.